let's kick this off. So I do have a confession to make, guys. It is now a live tracking demo rather than a flight tracking demo, because the flight tracker would only work 50% of the time, and I didn't want to take the risk. Being a seasoned professional, you can come in, mate. So we're going to start off. We're going to start off in an alternate plane of reality. And you're going to have to bear with me here, because there's a bit of an abstract analogy. Okay, so imagine a world where we had time. Exactly the same concept of time, second, minute, hours, days, whatever. But the way we chose to distribute time was different. We used something called the time machine. So if we wanted to get time, what we do is we walk up to the time machine, we put in our credentials, and we get 1 second of time. And that was it. Such an important piece of information in our lives. We was restricted to it because of the way that we chose to implement it. Okay, what are the consequences of that? Well, we're going to do a bloody lot of queuing. Because, time's a pretty important piece of our information. So we need to plan our days, we need to get to meetings, and all relying on getting our information from the time machine. It's going to lead to disruption. People are going to want more time machines. They want to be able to scale out the time machine. God forbid the time machine should ever fail. But thankfully, we didn't choose to implement time in that way. So we made it available to everybody who wanted to consume time. So we got clocks, we got watches, so anybody can have access to time whenever they want to consume it. But there are times where I want to press a button, call a method, and wait for a response. Maybe so for the green button, where I don't want to get projected, the updates every second, or I might want to do a bit of planning. I might go to a train station, want to know when the next 3 trains are, I can go off and get a coffee. But certainly with the red button, if I press that red button, I want somebody to respond to me pretty quickly. And I guess the moral of this story is, we've all built time machines in our software architecture. We've built things that when we look at them, we think doesn't quite apply or doesn't quite conform to the quotient of common sense. And, the message I would introduce here is that as software architects, designers, and developers, we've got a palette of capabilities. And the thing I always say, and the API days guys hate me for it, is there's been a profligate implementation of APIs because they're very easy and they've been very successful, and other things that we've tried before haven't been quite as successful. But it's led to problems in terms of, distributed monoliths and, poor customer experience. So if there's one thing that I'd like you to take away, is just consider, alternatives. If something feels like it should be asynchronous, then look at the asynchronous alternatives. Now, we have been on a trajectory that aligns with this. In the early days of integration, we had no way to call remote procedures whatsoever. We could just go to a different line of code. Then we had things like IDLs and object request brokers, SOA and messaging, until we finally landed on the nirvana of the API. And APIs were successful because they were simple. They delegated a lot of the protocol into a very successful protocol, HTTP. And, they really lifted up manageable and governance of our integration assets to the point where a lot of organizations are running successful API economies, monetized API economies. The request response pattern is not applicable to every kind of scenario. And, in the 5 years I've been with Solace, I've seen that generational maturity. From 5 years ago, no one was talking about event-driven architectures at all, to the point now where I think there's a maturity in some organisations, certainly where they're cashing in on investments they've made in event-driven integration, to be able to, repurpose that into analytics, on the upper end of the maturity scale. But I think at least everybody in this room would have a realisation of the, potential impact of event-driven architecture. Now, I'm going to make a prediction that the next aspiration of organisations is the ability to manage all APIs in the same manner. And what does that mean? Is that if I want to consume a REST service, I go to my API portal, I look at the terms of that portal, I assert that I've got the security to actually consume that, I can download the RAML, I can generate some code, and I can actually interact with that service. Well, the same for the asynchronous world. In the same portal, I'll search on the capability I want, I'll find out that it's asynchronous, it's an event, I'll assert that I've got the security to consume, I'll subscribe to that event, and then I'll generate the code that actually implements that asynchronous interaction. And to be honest, we're there already. The async API initiative is managed by a component of the Linux Foundation. Is it as mature as the REST API world? No, it ain't. But there's a lot of lessons to be learned and brought through the async API world, and a lot of the same guys are involved in the initiative to do that. Okay, so, in terms of events are everywhere. I'm often overwhelmed in terms of, the scope of use case that I need to be involved in. And in some circumstances, it shouldn't be event versus API. There should be the ability to create the event-driven API. And like I say, it's not only rhetoric. Here's the specification, and I took this from the async API GitHub repository, and it's a side-by-side comparison of the capabilities, and many of them are exactly the same. All this is open source, by the way. You can go in there now, you can specify an asynchronous API. If you don't want to use Solace as a message broker, you use Kafka or RabbitMQ or ActiveMQ. You can create a binding, and you can create an application acting as a producer, a consumer, or a processor, which is both. So it's already in production, let's say. People are using it in anger. So the difference between open API and async API is obviously, primarily the async API is asynchronous. It's in the title, but I'd say the interactions that it's supporting really are it's abstracting all the complexity, and there is a little bit of it, in how applications organize to connect and create these things called channels into the broker infrastructure, the event meshes. Once that's established, it's all about business logic that you're delivering, what is it I want the actual application to do. All right, with that little analogy and summary, I'm going to hand over to my colleague Vidyadhar, who is going to rev you all up a bit with a bit of interactivity. Yes. Isn't that right, Vidyadhar?
Yeah. So, hi guys, I will walk you through a bit of demo that we have created. So essentially the demo will cover all the aspects of technical architecture that we deal with, or the components that we deal with when we are building event-driven architecture. So in a typical EDA landscape, let's try to compare it with APIs. Generally the interaction pattern is request reply. You request something or you post something, and you either expect a reply or bare minimum you expect 200 OK. Whereas with event-driven applications, and by the way, EDA is not new. EDA has been there since mid-90s when technologies like IFCO, RB digitized the whole trading flows in the capital markets. So they have been using EDA, they have been using asynchronous, loosely coupled, highly scalable, it's not a new concept, but it's just that now with the mainstream, lot of business verticals adopting VBA, it has gained a lot of momentum and there's a lot of interest. So what we are going to do in this workshop, so we got 2 workshops today. In this first demo, we have built a sort of dragon boat race. So we will do a bit of racing amongst all the participants among the team, and we'll do first run. After the run, I'll go through how that is built using event-driven technologies, and yeah. So what we have got here is, what if you want to build a distributed phone-based game, right? So it's like you all participants will basically scan something, a barcode, and that will open an app on your mobile phone. You will be assigned to a team. So in this game, there can be either from 2 to 100 players. Generally, we will split you in 4 teams, different color dragon boats, and then you will basically on start, when I say get set go, you will click on the screen of your mobile, and whoever generates more clicks, their boat will row faster.
It's a race.
Yeah, it's a race. And the winning team will get some gifts.
Oh,
Yeah.
Not in the practice.
Yes.
Let's make sure the sun's up. I don't know if it kind of. might be a bit too low.
So Derrick, we got this
Yeah. So we go to
Chrome working, right?
No, we go to the. See, you're trying to operate like a Mac now, aren't you?
Yeah. This one?
It's not Chrome, it's Firefox. Just, do you want me to do it?
Oops, sorry. Yeah, you can do
I'll just break out of that.
Yeah.
Um,
So we are just launching the race.
Alright, so it's just setting up the race environment. Mate, I'm not.
You're
I'm
not connected
I'm not
to
connected to the
internet.
bloody network. See, but it's decoupled, so it's resilient.
Yeah. So see, while we are connecting to network, it is saying connecting. It is retrying. So the browser is retrying to connect, and once the connectivity is established,
We'll see if it is actually connected. I might just do a restart that. Should check the network. See, this is our lives, guys. Live
Yeah.
demos.
live demos. That's the typical thing with live demos.
Let's give it a different name. Call it Vidya.
And even this URL.
Oh, is it?
Yeah.
I think it updates that when you do that.
Yeah.
Oh, here we go.
So
Right.
if you can just scan that barcode at the bottom corner.
You're not buying any Solace when you scan the barcode.
So I see 2 participants, 3, 4,
Pink.
6, 7 joined, 8. So 1, 2, 3, 4, 9, 10 joined. Couple of you are remaining.
Oh, I would do it.
Okay. So we got everybody. So that's the race controller.
So we didn't allow for that. You're going to have to move Phil's head though.
Yeah.
I got an email. Oh, there we go.
So set, go. Yeah. Just tap.
Oh, there's usually a.
Yeah. He didn't.
Right, come on. You got gold in the front there. Big
Yeah.
race coming up man from
The yellow one is
gold. Ooh.
yellow team wins.
But that was only practice. Yeah.
So you see the most clicks 146, second most is 131, third most is 89, and worst clicker 32. So these statistics are basically from every individual mobile app. So there's one of you who has done 146 clicks.
Do we know when that is?
No, not yet.
Okay. I think it says on your screen if you're a winner.
Yeah. Did anybody?
Tell you the rank.
Oh, yeah. Okay. I bet you're
Hi,
multiple.
Daisy.
Anyway, that was just practice. At the end, we'll do a real one for
Network
practice.
history.
So, I mean, see, the idea of the game is very simple, right? We have this browser screen, and then you all scanned the code. After that, you got assigned to a team, and then you started clicking, and at the end, we crossed the finish line and we got some stats, right? So just imagine how would you build a game like this? So to build this, we would need a web server, typically to host components, landing page, etc. Race controller application, which is the brain, because there's a lot of interaction. So I'm running some logic on my laptop, which is the race controller, and then you all are the clients of that race controller, which are interacting with each other. Then you also have that one browser, which is the race display for participants, which is on your mobile. So that's the individual race participant, and there is an aggregated view on the browser. And mobile front end, either JavaScript or Android app. So the point that I'm trying to make is there are a lot of interactions happening here, right? A lot of mobiles connected, race controller application, the brain of the click counter. All of these things are happening in real time on your mobile network, which is not like very fast, and still we get that real-time experience, right? And by the way, this server is running in Singapore, if you can see from the URL. So how would you build a game like this? So what are the challenges? So imagine if you have to build the whole game using plain REST, which is like plain API concept, only REST, only HTTP. So REST versus messaging, I mean, some of the issues that you may have to think about, service discovery. So if multiple race controllers were running, how do players find them? So I can run multiple races, right? I can run one race for this room, second race for another room. So I can parallelly have multiple races going on with hundreds and thousands of participants participating across those races. So how that discovery happens, dynamically starting and stopping multiple races. Then another component, if needs to be added, how do you discover? So service discovery, all those kind of things. The second is how to signal start of race. Being impartial, how do I send a signal to all of you at one go so that you all are notified immediately and you can start taking action by clicking on the screen. So central controller must inform all players simultaneously, outbound server to client communication. So it's not like your mobile phones are polling continuously whether the race has started or not. It's like it has made a stateful connection to the central server, and on that stateful connection you are listening if the race has started. You are not asking. So as soon as I want to start a race, I will say start race, and it will send a broadcast message to all of the participants. So each player constantly polls to race to ask if race is starting. No, each player app runs a web server to receive REST. So let's say if this race controller has to send a notification back to mobile clients, do you run a web server so that you can get a REST request? No, so that is also not the case. The third thing is send each and every row event. So click, click, click. Everybody is doing that. It is getting into race controller. It is doing a lot of analytics on that. So how it all happens. Stretch goal. Let's say if you want to communicate amongst the participants within the team. So only ping to ping communication should happen. The ping to yellow communication should not happen. So how do you achieve that? So there is no server in between. It's only client to client communication. So how would you implement something like that? Again, a stretch goal. What if you want to send all these clickstream kind of analytics to your central warehouse so that all the clicks across all the races, across all the participants gets and set in your data warehouse. So these are like some of the challenges that we see. So let's see how we can implement it. So I mean, we have covered REST versus messaging. So we know that REST is good for certain use cases. So REST should be used where it is practical to be used, and there are eventing technologies where they should be used for solving those problems which are very difficult to be solved with REST. So event driven in action. So knowing what we know about event driven communication, how would we build this game? So building it the Solace event mesh way, all players and race controller are connected to the central broker. So Solace broker is like an event broker where polyglot applications can connect and exchange information. So essentially, my race controller could be built using Node.js. My race controller UI is a single page JavaScript application. Your mobile applications are or could be MQTT based or JavaScript based. My analytics application could be a Java based application or Spring Boot based application or .NET. So how all these components talk to each other without each other knowing about the existence of the other application. It's purely polyglot. So I can publish a message using JavaScript and consume using Java. So Solace as a broker will help you do that protocol translation. So at the heart of Solace is Solace topic. So somebody, I mean, if you guys have worked on PubSub, topic would not be new to you. Topics are like pretty old concept, but the way we have constructed topic or the way we have architected topics within Solace is significantly different compared to, take example of Kafka or IBM MQ or ActiveMQ or RabbitMQ. In traditional messaging middleware, you have to first create a topic and then publish a message and consume message from topic, right? Whereas in Solace, topics are not created, they are just a namespace. So it's just a string where you publish a message to. There is a semantic to how you define topic. It's basically an ASCII string that starts with different segments. So in this case, boat/meet/query. So which races are there? So for example, if you are the race participant, if you want to find out what all races are there, you will just send a query message on that topic and the race controller will respond you with all the races available. Then you will say boat meet ID join. So join this particular race. So when we send you a response, we will send you the meet ID. So let's say there are 3 races, you can send a message. I mean, that is how the mobile app is built. You will select this race I want to join. So behind the scene for that race name, there is a race ID. So that meet ID will be substituted in that topic space, and mobile app will send a message to Solace broker on that topic, boat/meet/meet ID, which will be the ID, and join. So race controller will know that this mobile application is interested to join in this specific race. So then mobile application, the race controller will assign that player ID to that specific race within that race. So these are like, different topic hierarchies that are playing behind the scene in the interaction between your mobile and the race controller application. And these topics, by the way, are not created on the broker. They are dynamic on the fly. So any questions so far? So how it all looks like from the visualization perspective also, we have got this thing called as event portal. So when you are building a distributed, loosely coupled microservices based architecture, you have a lot of microservices, they are exchanging hell amount of data and they are interacting with each other using the topics. So what we are showing here is these are different microservices composing that racing application. So race controller, player board, new race. So these are all participants which are either publishing message or consuming message from the topic. And these meet query request, meet query response, join meet request, these are all something called as events. So this is the picture of Solace event portal, which is used for weaving your microservices application with each other using the right topic taxonomy. So this is like a single pane of glass where you can go within your enterprise and look at what all events are available, how they are interacting with each other. Right? So that's a design time view, design time perspective of building the microservices based DDA architecture. So event driven in action, we just talked about it. So how do we do service discovery? By making a request to that topic and we get a response so that we know all the races. The second question was how to signal the start of the race. So players subscribe to all related message on board/race/race ID. So that's the topic. So all of you will be subscribing to that topic, and when I want to start a race, I will just say start. So that start makes a broadcast. So it sends an event to all of you, and you all get notified simultaneously at the same time that the race has started. And then you start doing click. So the third thing is send each and every row event. So yes, each and every tab becomes a message that goes to Solace broker over your 3G, 4G, 5G connectivity from your mobile app. Then you use, like, the mobile application is built using WebSockets, and this can easily scale up to thousands of messages per second. I mean, the broker can support like huge amount of messages in terms of the ingress and egress. So the fourth thing is stretch goal, allow teammates to communicate with each other. Again, topic, board/race ID and /green. So when I say one of the mobile is publishing on that topic, all the teams or all the participants in green team only will get that message, because they are subscribing to a topic that is ending with green. And we can have access control list. So I can say that pink team should not be able to get the messages which are published for green. And these all ACLs are highly dynamic, very flexible to configure on the broker. So this is what we called as entitlements. Who gets to see what? Not everybody is entitled to see everything. And the last thing is stretch goal. Again, let's say if I build a big data warehouse that's sitting in, let's say in AWS, we can use event mesh, and the consumer, let's say if I build a Java based application in AWS, I can let that Java based application subscribe to both/greater than, provide appropriate ACL permissions. So ACLs also work based on topic. So on that application which is connecting to broker and subscribing to both/greater than, I will say allow this application to subscribe to all the topic hierarchies starting with one. So it gets all the data. And when it subscribes to that, doesn't matter what race it is, what participant, what click, all the events will get ingested into that consuming application. So that's pretty much about it. I mean, that is what I wanted to cover as part of this workshop. So the point, some of the key features that I would like to highlight is, you might have seen, topics are very powerful in Solace. They are the heart. Like, if you understand and if you get the feel of how do I use topics for exchanging information, it solves two things for you. One is efficient data distribution, gives you the flexibility, because the topic hierarchies are so flexible, and then it's a complete decoupling. You can onboard applications. So let's say today you start building an application, let's say in payment space, and you are emitting payment event today. Tomorrow, if you want to, let's say, build, so currently, let's say, assume your payment processor is processing all the payments across Australia. Let's say a regulation comes in and it says that I want to process NSW payments differently to, let's say, Victoria payments. How will you do that without impacting your publishers? So if you have state as a topic segment, you can create two different consumers, one for NSW, one for Victoria, and when the publisher is publishing, it will include the state in the topic, let's say NSW Victoria, and then you will be able to route and filter the events within the broker. So topics are like heart, core of Solace. And that is used for data distribution, access control, building event mesh. So let's say you have a geographical distributed mesh of brokers. So these brokers you can connect together and they form an intelligent network of subscription management. So it knows, let's say, there is a broker in AWS and there is another broker in Azure. You can connect them together. If an event is published in Azure and there is a subscription in AWS, these two brokers are always in exchanging information mode. They know who is subscribing to what. So if somebody is subscribing to an event that they are entitled to subscribe to, when the event is published in Azure, the broker will take care of routing it to AWS without you building any kind of bridges in it. And if nobody is subscribing in AWS, the event will not go there. And And this can be either in the same region, or these brokers could be the one in Sydney, the second one in Singapore, third one is in London. You can build any kind of mesh. And when we build a mesh, we have some WAN optimization capability. So for your long distance lines, we can optimize by adding compression onto those links and throughput more data, like exchange more data. So that's pretty much about the concept and how this can be built using Solace. You might have seen there is no web server in the picture. It's a single page application. There is a microservice, which is the Braille, and there are mobile apps, which are clients, all exchanging information using Solace as a central broker. So let's do the race again and see who wins.
Do the race right at the end.
Right at the end? Okay.
Yeah.
Yeah, sure. What is there?
Oh God, I feel like I've been stood up all day.
So any questions?
So we'll get through the next bit. Yeah. So that was a great introduction to Solace's capabilities of using an event broker, creating a decoupled application and routing information between these applications using topics. Thank you, Vidyadhar. Okay, so we're going to build on that knowledge. This is what you've all been waiting for, no doubt, which is the tracking application. So I do have a little bit of a confession that the flight tracking application would only work 50% of the time, and I wasn't brave enough to hope that the 50% would operate here. So we've got another tracking application, but we'll go through the concept, and it really builds on the knowledge that Vidyadhar has introduced in terms of topics. So what we're going to do is we're going to look at the existing tracking system, which uses topics to identify a region of interest that we want to actually focus in on tracking. So we're gonna look at a couple of examples here of topics and topic hierarchies, and we often call these taxonomies. And I might come into the audience here, break down the barriers of. So each one of these levels is actually descriptive, and Vidyadhar kind of introduced this concept previously, where we may have some level of domain or department, but the data that is actually injected into these topics is what I call a classification. And the way to actually model these is to look at the payload of the data that you're trying to represent and work out what the key attributes that you're going to use to route and filter that piece of information, that event between the producers and subscribers, and then elevate those into the topic namespace. If you think about in the days when we used to do content-based routing, that's exactly what we used to do, isn't it? So we used to do it very inefficiently. So we'd get a message, and we'd deserialize it, we'd look at the attributes, we'd use a bit of XPath, and then we'd send it on its merry way, serialized again. And it was a very inefficient way of doing it. So what we've done is made it more efficient because this lives in the header of the message. So all we need to do to get the same benefits of content-based routing is look in the message header, and you can get scales of performance improvement. So step one to your effective event-driven architecture is spend a bit of time, and it might be a job for an analyst or an architect to actually define a really good topic hierarchy or taxonomy. Now, many of these levels comprise of variables, even enumerated values or bounded lists. So this is what we've got an example of a manufacturing one here. So this is what the hierarchy might be represented as. So when a message is actually published, the values are provided by the publishing application or the producing application to actually classify that instance of the event. Now, obviously, there's a growing set of tools to support that activity. People have used spreadsheets in the past. I'm sure they did that in the early days of the API also. but there's tooling now being delivered by Solace and other vendors to enable that activity of modelling to be better supported, usually through some kind of workflow process as well. Now, the example that we're going to be using is actually providing the ability to track buses. Actually, buses which are operating within a jurisdiction, and we're going to use the power of topics in a quite innovative way. And in fact, there's a whole paper that supports the algorithm behind this. This program was written by a colleague of mine called Aaron. He's actually the developer advocate for Solace in region. He's a very smart guy. He's a great developer. But his concept was we should be able to track something. So events, like Vidyadhar's application, the events are the kind of button presses. In this case, there's devices deployed into the buses and emitting events in terms of is the bus moving, are the doors open, is it in proximity to another bus, is it broken? We want to raise an alert in those circumstances. However, the smart thing that Aaron did is he realised that if he actually used the lat and long of the location of the bus, he could actually overlay either a rectangle, which was his first view, and then a polyglot, and actually restrict the view, the scope of the buses. So we can say, we want all the buses in this region, or we could draw another one and say we're only interested in those buses. And the only thing that changes is the subscription. So the application, which is actually visualizing everything, like Vidyadhar's application before, is a JavaScript application, and the only thing that changes is the subscription. So this is what it's going to look like when I actually put it up there. I will show you the demo. So you'll see when the actual scope changes, and like I said, there's originally a rectangle. You see when you're making an abnormal shape, it becomes a series of rectangles in an area. So pretty smart. So in this circumstance, it would issue one subscription. When there's loads of little boxes, because the shape's a little bit irregular, then there would be many more subscriptions. And you'll be able to see how many subscriptions are actually being generated by the application. Now, I'm not sure what benefit we get looking at the next slide, because it looks awfully like that one. But with that, I might jump into the application that we're talking about. And I'm fairly sure I didn't do it. Solace, is it? .com. I thought it was just bus. Oh, here we go. It's a little bit slow. And you'll see that these buses appear. So each one of the green blobs, is a bus. And you'll see as they come through this intersect, and they might take a couple of ticks to update. Look, this one's actually faded away. So it's going out of our. So we're only interested in the buses that are operated in the current rectangle. And the thing to look at here is we've got one subscription, so all of that's been managed by a single subscription into Solace. So you can see what the subscription being issued is, and you can actually see the buses and each of the individual topics that are being published into the event mesh. So it's actually displaying each one of those. Oh, my battery's running low. Sure, we can sort that out pretty quickly. Yeah? I'm not sure I trust it. For 15 minutes. Where do I plug it in? Oh, yeah.
Sorry, what city is it, by the way?
Well, it's actually Singapore, this.
Oh, you said, yeah.
Yeah, so I can actually zoom out. So There you go. Now, this is a simulation, I'm going to call it, we're not doing it real time. But we do have a solution where, similar to this, there's optimization of the kind of bus management within Singapore, which is based on, a solution very similar to this. And we've not just stolen all the code, by the way. Now, so what can we do with this? I'm just wondering how this is going to work with my touchscreen. Now, I can change the location. And as promised, I can restrict the scope of that. Now, it's probably not as accurate in this sense, because what Aaron's done is increase the number of rectangles. Because it's a regular shape, he basically divides it all up. You can see some of the rectangles are extremely slim, some of them come out of the line slightly, but it's not a bad job. But what it's done is increase the number of subscriptions now to 70. However, you'd see that the message rate has reduced. Now, each one of these is kind of similar. So we can click on that one. So these are the events and the payloads. I know how often we talk about these as kind of mysterious things. You can actually see that we would call this the topic. So the topic is published, and this is exactly what a message looks like in Solace. So the topic is the header metadata. You can see the status, it's stopped, this one. And then there's a number of data that goes along with that, representing its location and a number of other telemetries that are associated with that. So I guess that's what I wanted to show you in terms of the tracking demo. So I'll ask if there's any questions related to that or anything else you see before we go into the crunch match of the final drawing board.
Yeah, maybe Derrick, what you can do is just delete the whole rectangle, so it removes all the subscriptions, and we can also filter by route number. So let's say if I'm only interested in getting the events from bus number 23, so I can say filter by route number 23.
Is there a 23?
23, yeah.
Yep.
Just tab out. And
Yep.
so you will see the subscription has changed in the bottom line there, V2/023 star.
Yep.
So now what it is doing is, it is only receiving the events for all those buses whose route number starts with 23. And we can also do bidirectional communication. So I can click on a bus, that will show me the data, but that bus driver app, I can open that and I can say that send a signal to this specific bus. And this all again, no web server, no REST proxies, nothing else, all broker and intelligently built applications, microservices.
Well, the significant thing that happened there is we issued a new subscription and dynamically our view of the data changed. Solace is a different architecture. You can compare it to something like Kafka. Filters in Kafka, traditionally, topics are stored in logs, and to perform a filter, it's really a log function, log activity, create a new topic. We've managed to do exactly the same thing here, just by altering a subscription. So, it's really using the Solace broker, Solace Router as a broker. It's dynamically adapting to the subscriptions that are applied to it in terms of the data that it's filtering and routing. Is there anything else you want to show on? Yes?
In this model, what you deploy to the bus, you're retaining a lot of information about speed, RPM, the status of whether it's moving or not moving.
So a device, typically some kind of device, I think
So in the real implementation with Land Transport Authority in Singapore, we collaborated with Mitsubishi Heavy Industries, MHI. So MHI has built an onboard unit, OBU, that is emitting MQTT events onto Solace brokers. So they use 4G connectivity. Singapore being a small island nation, the coverage is very nice. So these buses are emitting 40 plus different attributes about the bus operation, including lat long and other statuses
Yep.
onto these brokers, and there are backend applications which are doing intelligent things like bus bunching, routing, things like that.
Another kind of similar initiative that they've implemented in Singapore is intelligent road pricing. So basically, you know, if there's congestion, they'll incentivize drivers to take an alternative route. And again, you know, it's the same principle here. There's some kind of monitoring, providing data events into some analytics platform that's able to make decisions based on conditions. And you know, that's a good example. Okay, I'll see you such an expert video. I'll let you operate the Dragon Ball race again. Yeah?
So now that you know how driving
I'll be the
is done,
commentator.
let's do another round. And by the way, just like little secret to generate more
Let's
click.
ask the question though.
Yes.
What's the secret to success?
The most clicks.
The most clicks, the most events, and how do you create the most clicks? Using the most number of fingers. Yeah, so scale. You can scale the fingers. Sorry, that's weird. Starting to lose it. I'm gonna participate this time.
What's that? So how do you do it? Like DB? Oh yeah. DB / question mark VK1. Let's start a new race. So we call it the winner's race. Oops. Yeah. So again,
I'm all
so when you finish the race, please keep your mobile screen open because you will have winner, or like, you know, first or second or third.
breezy. Very appropriate. So yeah, leave the app open so you can see where you've. How many have we got? It must be about 50. Queenie, you're not doing it.
It's not liking it.
Yeah.
Okay, ready? Go.
You didn't say it.
Oh my god, yellow is like so fast.
Oh,
So now the controller, so most clicks to 43.
7 out of 13. So who was what out of 13?
I didn't even start. Like,
Yeah, definitely not one. Come on, don't be shy.
Yeah, my virtual fingers won.
Oh, there you go. That's a round of applause here for the winner. The best scaling. We've got prizes.
Yeah. So number
Well,
one,
yeah,
number
two.
two, and number three.
The screen didn't move.
Who's number 2?
Who's
There
number
we go, this gentleman here. So they're the only bit of swag that we're not giving out to everybody.
Yes.
So you've got, I'm not saying anything good, it's just.
Is there any number three?
It's exclusive. Right, anyway, I think that's the end of our workshop, and you know, there's one thing I'd like to, you to walk away with is that you just consider other patterns other than, request response when you're building your applications. So
in this demo, we actually touched upon all the different patterns that Solace supports, and from fundamental application architectures perspective, all of them are important, like request reply, publish subscribe, fan out, like notification, fan in, lot of ingest of events from your clicks coming into that controller application, which calculates how many clicks individual player did. So different kind of message exchange pattern for your loosely coupled application. So all of them are supported within the same Docker. Alright, yeah, that's pretty much about it. We had, and good that all the demos worked.
we didn't get the sound, I was a bit disappointed. So, there we go. yourselves a big round of applause, guys. Everybody a winner.